on number 5, they're given a 64 to the 1/3 power. They're going to ask us to do stuff, and I'm just using this one again as an example for just giving you some notes. When we raise something to a fraction, this is really equivalent to the cube root of 64, and here's why. If I have the 64 to the 1/3, the number on the bottom of the fraction is the root I'm taking. And the number on the top is the power I'm raising it to. Now this is just take the cube root of 64, and then whatever that is, you raise it to the first power. Power I raise it to. I know you can't read that, but unfortunately it's the best I can do on an iPad. It's on our board in our classroom, but it's easier to write on the board. Okay, so now, the reason I'm writing it this way is I can have something, for example, before we do problem number 5, I can have something like 64 to the 2/3 power. You always, always, always take the root first. There's most of the time, it's not going to work if you don't. So what this is equal to is taking the cube root of 64 and getting that result, and then turning right around and squaring it, because the 3 means it's the cube root. The 2 on the top means after I cube root it, I'm going to square it. I know, but I'm giving you another example. Yeah, I'm giving you another example. The reason I'm telling you, going ahead and saying this about the top part is because it's not always going to be a 1. For instance, here, if I'm working this problem that I'm giving you as an example, the cube root is 64. If you remember, 4 times 4 times 4 is 64. The cube root means what 3 same things do I multiply together to get 64? You multiply 3 of these 4s to get 64, so the cube root would be 4. Now, if I wanted to put that in my calculator, what I would type in to get the cube root would be I'd type my 64, and then I would hit the little power button, or the little caret thing on my calculator, which is below your clear button if you've got a TI 83 or 84. And now to do the 1/3 power, you'd have to use a parentheses because it's a fraction, and you'd have to put 1 divided by 3 to get that in your calculator. There is another way to do it. You can go to the math button, but just because there's not a button for everything, or it's more difficult to do it, you have to actually go to a menu. It's just easier to slop it in that way and always do it that way. It actually ends up quicker most of the time. So you could put this in your calculator, and it would tell you that it's 4. So the cube root of 64 is 4. But now in my other example that I gave, I put a 2 on the top, so it means I'm going to raise it. To the second power. I'm going to square it when I get done. This would actually be equal to 16. And that's how these things work, and they show up all over the place the further you go in Algebra 2 especially, and then you'll see them again in Pre-Cal, and of course they can show up anywhere after that. But anyway, that's how you kind of have to read these things. Now, I haven't done problem number 5 yet. I'm just kind of trying to show you how these fractional exponents work. A lot of time, we don't have a whole lot of rules that have to do with radicals. We've got a lot of exponent rules, so we tend to work with things in this form right here. But there are times when switching it over is easier, and this is one of those. If I want to know what 64 to the 2/3 power is and I didn't have a calculator, or I wasn't allowed to use a calculator on that problem, I could figure it out by hand by using radicals a whole lot easier.
You didn't solve 5.
I did not solve 5. So,
did.
Oh, I did?
Yeah,
What
it says raised to the power.
Okay, let's see. Oh, actually, I didn't do that. I saw that, and I thought, okay, we need to know what this means. So it says, evaluate 64 to the 1/3 power by first writing 64 as a power of 2. Oh, what is 64 as a power of 2? It's 2 to some power. So what they want me to do is rewrite 64 as a power of 2. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, 16 times another 2 is 32, and 32 times another 2 would be 64. How many 2's was that? It was 6. So what they're telling me to do is to write 64 as 2 to the 6th power, okay? And then operating with the exponents. What does that mean, you think? Yeah, we got a power. If I rewrite it that way, it's a power to a power. Would I have done this really? No, I wouldn't have done this. I would not have thought to do this. They're just having you play around with it. This is 2 to the 6 to the 1/3 power, and your exponent rules say you multiply a power to a power. 6 times a third is the same thing as 6 divided by 3, so it is 2, and 2 squared is 4. You can do all kinds of things with exponents. What he just told you to do, I probably wouldn't have ever done. But anyway, it says then evaluate it directly in the calculator. So in your calculator, type in 64, then hit that little caret button, and then if you haven't done it yet, type a parentheses for your exponent and type in 1 divided by 3 and then hit enter and see if you don't get 4. You should get 4. Everybody get it? Okay, so y'all are all doing okay with that. We are going to do 6 on the video. 1/4 to the negative third power. Now, normally with the negative, we said we moved it to the other side of the fraction bar. I could do that. I could put a 1 and put a 1/4 to the third power, and I could figure it out that way. But here's the quicker way to do it. When you have a negative exponent, instead of doing this, if you will remember this, a negative exponent on a fraction flips the fraction. This becomes 4 over 1 to the positive 3 power. Let me prove it to you. If I were to do it the long way, it would be 1 over 1/4 cubed. So that would be 1 over 1 cubed is 1 over 4 cubed. We're just going to write it as 4 cubed. Now, I don't know if you remember, all the way back to 7th grade, 6th grade, they do it even in 6th grade. How you take care of this is you say, you know what, if I got a fraction on the bottom, let's make the top into a fraction. We'll just write 1 over 1. And if you remember how to do complex fractions, and you're going to have to know by the end of the year how to do this because you're going to get all kinds of wonky things, you take the numerator and you multiply by the reciprocal of the denominator. So that means flip this denominator. That becomes 1 times 4 cubed is 4 cubed, and 1 times 1 is 1. Isn't that what this up here that I did is going to simplify to? 4 cubed is 4 cubed. 1 cubed is 1 cubed, or 1. 4 cubed actually ends up being 64. There are some cubes and stuff that you need to know. 4 cubed to 64 is going to show up a lot, so I would make sure that I kind of got to the point where I could kind of pop that one off. You can always use your calculator, but it's going to slow you down if you have to do it all the time. On 7, he says evaluate 7/3 over 7/3 by subtracting the exponents. Now, it's 7 to the 3 minus 3. You might be going, well, do I put it on the top or do I do it on the bottom? Don't we always put it on the side that the bigger exponent is? Mm-hmm. But notice what happens. You really don't have to think about that because that's 7 to the what power? 0. Yeah, 0 power, and anything to the 0 power is 1. So there's actually another question there. He says evaluate it by multiplying out the numerator and the denominator. Okay. 7 cubed over 7 cubed. That's 3 copies of 7. This is what Charlotte did. Over 3 copies of 7. Except you could have seen it without doing this. He's just telling you to. 7 goes into 7 one time. 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 And it kind of keeps on going. 1 times 1 times 1 on the top is 1. 1 times 1 times 1 on the bottom is 1. And 1 over 1 is 1. So it works. And again, you know, what Charlotte said is, it's the same thing on the top, on the bottom, so that goes into that one time, that goes into that one time. You could have seen right off the bat that it was 1. But he's just trying to get you, the author of the book's trying to get you to think about all kinds of things you could do. Okay. 8 says evaluate 789 by writing it as a power with a fractional exponent. Okay. One thing I could do is, if I want to write a fractional exponent, a square root is something raised to the 1/2 power. I don't know if you knew that, but aren't you looking for a square root? Is a square root is what is the thing that I multiply 2 copies of it to get something, right? The square root of 9 is 3 because 3 times 3 is 9. So we're looking for a pair of numbers that are identical that give us our answer. So I could write it this way. I could write it as 789 to the 1/2 power. Now, unfortunately, if you try to do this, there's not a whole number, so you'd actually have to put this in the calculator. I could type it in, your calculator, you could hit second x squared and then type in 789 and you could get the answer. Another way you could type it in the calculator is to hit 789 raised to the 1 divided by 2 power. If you do that, it is not a nice, pretty number. It is like 28. If you're doing it right now to try it, 1, blah, blah, blah. It just keeps on going, and no matter which way you type it in, you're going to get the same thing. Okay, so that's just another thing he's trying to show you. A square root is the same thing as something raised to the 1/2 power, and you're going to need to know that because you're going to be switching back and forth. Maybe not in this lesson, but eventually it's going to show up later this year. That's what I was laughing at earlier. Hypertension loses points on a test for saying 8 to the negative 1/3 is equal to 1 over 8 cubed. That is not right. It's not right, so we got the problem wrong. Tell Hi what error he made and how to avoid it in the future.
Shouldn't it just be 3 over 1, or it would just be 3?
Wait, what was his name?
His name was hypertension, like high blood pressure, hypertension. Okay. Now think about it. What he got right here would have been 8 to the minus 3. Wouldn't 8 to the minus 3 power be 1 over 8 cubed, right? This 8 to the negative 1/3 power, here's how I could think about this. Let me write it like this. 8 to the negative 1/3 power. Let me make 8 a fraction by writing it 8 over 1. What did we say a negative exponent does to that base there, to that 8 over 1? What do I do to it? I flip it. It becomes 1 over 8 to the positive 1/3 power. Okay? So you flip the base. That base part is the what's inside the parentheses, the thing that you're raising to the power. This is your base. And remember, this is the exponent, is how we would label this back in junior high. So I flip my base, and then the exponent becomes positive. Flip base, exponent becomes positive. And so this would actually be the same thing as, now I can't think about it in that form, but this is something you could do without your calculator if you rewrite it. This is why it's good to know how to rewrite it. This is the same thing as the cube root of 1 over 8. Now when you cube root something under a radical and it's a fraction, you can say that's the same thing as the cube root of 1 over the cube root of 8. You can just cube root the top and cube root the bottom. What's the cube root of 1? What do you multiply by itself 3 times and you can get a 1 out of it?
1.
Yeah, 1 times 1 times 1 is 1. So the cube root of 1 is 1. What could you multiply by itself 3 times to get an 8? Yeah, 2 times 2 times 2 is 8. 3 2's multiplied together make the 8. So the cube root of 8 is 2. So I could do that without a calculator. I could use my calculator, but honestly, we kind of want to get to work toward the point where we're not on stuff like that, because that's just, we should be able to mentally be able to handle that eventually, even if it's new right now.